Okay, hello everyone. Jogang, let's continue writing. Alright, first we need to determine whether we want to save it locally, because if we want to save it locally, we need to perform a series of operations, and here we will receive the information about whether to save it locally from earlier, if we want to save it locally. First, we need to determine our current, this thing, it's DX century. We get its path, whether this path exists. First, this path must exist, and at the same time, the file's extension must be WA. Then we consider that. Only then is it a valid path. If this path is not valid, then we consider this path to be invalid. We will directly call false on this information. Then the generation fails. Then we release the resources. We just won't create the socket directly because we think you didn't write the path correctly. So here we give it this. It should be this lock. It should be it. Okay. Then for the log we use, it should be this one. Then let's take a look. It should be here. Also, we printed a log indicating that the path does not exist here. Now we also check the suffix. If there is an issue with the suffix, then we also return it back. If there is a problem with your suffix, then this is also incorrect. It's also not appropriate. If all these things pass, we won't bother with it. We'll consider it done this time. This is relatively simple. Just log a message, then make a call. As for the success or failure of this call, we'll write it along the way now. If it succeeds, actually, failure is relatively simple. You just need to return this thing back. Failure is simpler than success. Failure is relatively simple. Success is more complicated. For success, we need to do it this way. For success, we need to add this object to the root here. Then, in the next frame, we remove this object. After removing it, we then pass this pointer to our blueprint. This is to avoid the object being garbage collected at the end of this frame, so that the object is not garbage collected. This is a very crude approach, but it works. Another approach is to give this UObject a flag so that it persists during this frame. That is a persistent reference. Right at this frame, you don't have this object, give it a wall reference. That way it won't be recycled either. So this is a small detail that requires everyone to delve deeper. Consider and think about it. This part is necessary. Okay, then let's go back here. Next, let's determine the string that was passed in. First of all, this string, it definitely cannot be empty, right? If this string is empty, then we consider that this is also incorrect. Because if you send it empty, then Xunfei will report an error. So here we follow the same old routine if it is empty. We log a message and tell it that this thing here is empty. This thing is incorrect. We just skip it. Then if all these checks pass, we then, in the next week, we go to the next week. And only then create this Weibo post for it. Right, because we have a lot of tasks this week. We want to avoid putting too much pressure on him. Right? Now let's actually create this WebSocket. First of all, we still prepare our server's URL. As for this address, it is actually this address. So where does this address come from? Actually, it's very simple. We can see that address here. Without adding the S, it is this address. Okay, so here it is gate, here it is gate. That other place is more troublesome. Since this is a gate, then we need to call a method here so that it can assemble this URL. So how do we assemble it? Let's look at what we did before. Didn't we write a method to assemble it? Then I took a look. The method we wrote before is here. It's right here. It's this method. You'll see this method it's our host data post. But you'll notice this is post. Here it's get, right? So we just need to change it. This position is the same because this algorithm is exactly the same because its current algorithm is its latest general algorithm. This algorithm, how does it anchor it? Still following our old routine. No need. I'll explain this part to everyone again. Right, he just concatenates it here and then just signs the rest. So first, for this single, sign this signal. The signal is composed of 3 fields. These 3 fields of the signal are respectively is using host data request inline. Then these 3 fields, these 3 brothers, we perform a Hemaxis 3R56 signature algorithm. After the signature algorithm, we base Lixu encode it. After base, place Sir encoding it. Then we assemble our authorization like this. After assembling it, we then basics of EFU encode the early illusion. Let's see if we do it this way. Obviously, we also do it this way. You can see, first, we assemble this signature. The mind is these 3 brothers. After finishing the assembly earlier, we use our hashing algorithm. After the algorithm is completed, we reconstruct the original token. Then we can simply base-x4 encode the token. The algorithm in the middle is the same, so we can use it, but we need to make a change. So how do we change it? We can change it like this. If we give it a default parameter, this parameter is called boolBget, whether it is a get, then we set it to false. Set it to if else. So after we change it here, we need to change it here. Our function implementation is here. Here, let's take a shortcut. We don't want to write this code again. And then if we are here, we only need to change this. If it is get, then we don't want it to affect our original code. So here we paste it up. Okay, here. Then we are here. If it's get, we change it to get. That's it. Okay, then we go back to where we need to call it. We should be calling it here. Here we need to assemble our URL. So obviously, we need to include this header file. This header file should be here. It is this header file written in our third-party library. It's this one. Oh, it's this one. It should be this one. Let's include this header file. Okay. After including it, let's open it. We need to use this method. Let's copy it out first. It should be in. It should be here. There should be a method here. This one is called sum. Let's zoom in a bit. Sum's URL for the number of writes. It should be him. Yes, what we need is this method. So we need to pass these parameters in. Then we can pass them to everyone. First, we pass in this original URL. So that's it. Next, we need to pass an app secret. App secret. Okay, this is our default. Then there is also an app key. Okay, this is the API key. Then next, we need to output our protocol and the URL. So let it connect. This is the protocol and URL of our server. Let it output from here. Okay, then here we need to set it to true. Because it uses get, we reuse it here. Actually, okay, after it executes, we can get the server URL. So what do we do next? Actually, here we just need to call load var account. Then here we create a WebSocket. This parameter is actually useless. This parameter is not actually used. It might be used elsewhere. This particle protocol, so we can ignore it for now. Okay, so after we finish creating it here, we go ahead and bind all 5 methods we just wrote. These 5 methods are still empty, right? So after we finish it, it will look like this. You can see these 5 methods. Next, we will further refine these 5 methods. Okay, what should we write for these 5 methods? Let's go through them one by one. First, let's go to connection established. Let's write connection failed first, because connection failed is the easiest to write. The idea is the same as our previous failure handling. Here, we will directly let it pull a log. Pull a log. Okay, here. We'll just log it right here. Then our call failed. Then we directly release up. We don't need to. This close, this repo, give it to him. Right, because we've already been closed here. Actually, because it's reporting an error here. Actually, you don't need to actively close it because they never connected successfully. It's not in the connecting state all the time. Okay, when the connection is successful, we need to print a log. That is, we need to let ourselves we know it connected successfully. Then at this point, we need to take our NC string and convert it into this base-x4 encoding method. So we need to prepare a method to do this. So how do we do it? We'll provide a string base lookup. Let's call it Xunfei TXT. Okay, we'll write a method here. We'll write this method here. We'll write it below. This method is quite special. As for the name of this method, we call it. Let's just call it. We don't have to write it in crystalline form either, because we only use it in this one place. So it takes a uniform from Unreal Engine. converts it to UTF-8 encoding format, then performs basics for encryption on the encoded uniform string. This part is a bit confusing, right? No way around it. It's just that confusing. Because this thing, why am I explaining this to you as well? It's because it's really confusing. So here we first prepare our encoding of a uniform string, then prepare this empty, then this is where we need to call it. We haven't passed it in yet. So here we first distinguish a version. I'll first paste the D version. If you are in UE4 or UE5, you can do it this way, using our old method. After finishing, encrypt it with this code. This is fine if you are in UE5.1 or later versions. Then we can use swimcast. This writing method also passes. Just convert this tchar into this UTF-buffers char, then get its handle, get its pointer address, then the pointer length, then perform encryption. Then finally we return this information. That's it. Okay, this is the method we need to use. Okay. Let's check if there is anything else here. Let's do it this way. Let's still expand on this for everyone. You may not use it here. You may use it elsewhere. If we go back, that is decrypt the basics for encoded UTF-8 string into, standardize it into the engine's code string. How should we write it? Then let me write this code for everyone. First, we prepare a string code, right? Then we prepare a piece of data here. We first type the data we want to pass in and decode it into this, that is, first decoded into. This base looks for encoding. Let's handle it first. After handling it, now we have different version. If it's on the slow version, we just reverse it directly and let it execute. Then if it's on a high version, let's just execute it like this. Okay. Then finally, we calculate this character. Just return it. This way, it looks like it's the same. It should be roughly the same. Anyway, as long as it works, that's fine. Okay, so these two methods are written for you. Then after these methods are written, we come to this connection successful part. So at the connection successful part, there are actually many things that need to be completed. Here we are. Here we call this method. We let it do the, okay, what we pass in here. It's the previous non-empty payment calculation. This way, we have this piece of data correctly converted to encoding conversion first, and then basics for encrypted. After the encryption is complete, we complete here the responsibility of our APID. We can see there seems to be a problem here. Let's take a look. This should be fine. Why is it here? The reason there's a problem here is also very simple. Because we set it to has fate. Because the user, you cannot let the user set this value because they don't understand. When others use this plugin of yours, they don't know, and then they directly put the desired value here. So we don't let them do that. We must handle it manually ourselves. We only expose to them. This is what we call encapsulation. That is the feature encapsulation we develop. We just let them only modify the parameters we provide to them. Then here we are just doing a simple data restriction. Is a clamp of a size value. Okay, these things are the data we need to send. We only perform the verification process on the direct rate inside. Then we prepare a JSON. We take our require info. Just find this require info. We defined it in the previous lesson. Convert it to JSON. Then we can directly use the socket here. Send it over this place. It will automatically convert it for you. It will automatically convert this file to UTF-8 for you. So you don't need to just send file directly like this. Okay. So after we send it over, it will keep sending messages. Let's not for now. Let's not parse the messages yet. Let's test first whether this thing can work, right? So here we also need to write some code in close. Write it. We'll just do a simple close here because we don't allow users to close it. So we suggest that the connection must wait for the connection. Wait for the server to close our connection. Or we want to close the server connection after receiving all the data. Do not let the user intervene in this process. Okay, then we will print the string we received here. Okay. After printing is done, as for the rest, we won't write code for it. The rest we don't need to write. Okay, actually for the rest, we could also write it. We can write it. Let's take a look. Let's see what message he actually sent. Okay, alright, let's hurry up on our end. Let's compile it. We'll send a word count now, then let's check the cost. See if we can get the correct thing returned. Alright, I'll start it directly now. Then let's enter this level, and then write this blueprint. Alright, we are now inside the level. We find this TTS thing. Okay, here we need to obtain the key, then pass in these texts. We don't need any of these for now, so let's keep them as default. Alright, I've connected it, and here we retrieved our game instance. This is because we want to store the key in a unified place. So we use a game instance to store this key. Then here we send this request. Let's check that none of our pins here are in use. This pin should be useful. We can see that we can print a lot. This is the TTS execution pin. Now let's execute it. Press 1. It will execute these. We'll ignore them for now. Press 1. Okay, this place reports this error. Right, this reusable association. Okay, we found this issue. It is because of this reason. The error just now. Usually, it's because the permission check failed. This get must be all uppercase. So how did I find this problem? Because I have a version that already runs successfully. I set a poll, then I set this parameter to be the same. I found that it was different after encryption. Then I checked the encryption algorithm flow, and it was all the same. So it's just possible that we made a mistake in this part in the middle. So it's the case sensitivity of this part. It is case sensitive. So here, we capitalize these gats. Then let's check the result again. Yes, this version should be correct now. Yes. This part was quite difficult to troubleshoot. It took me about 10 to 20 minutes, because I asked my teacher. It seems like in this version of mine, versions 5.4 and 5.3 could both run through, but now I can't run it through, so I had to get its binary data and compare them one by one. Okay, now let's take a look. Okay, now let's execute this one. This time, we should pass it completely. Okay, you can see it, right? You can see that this side is the data he sent. This is the data we sent. Right, look, this is the data we sent. This is the encrypted data, and then this is the data we receive. You can see it is streaming. You can see there is a segment here. It says 0 message, successi, scasita, data. Well, this data is very long. Then let's scroll down further. It is usually a single segment of data. It can't be fully sent in one go. It should have multiple segments of data. Let's take a look here. Let's find it. We should be able to find OnMessage. Okay, you can see it should be split into 2 pieces of information, right? Split into 2 pieces of information, and then it was sent like this. Look, here's one piece. Okay, see if they are using the same remainder for drawing, and then this data. We can't see it. Actually, inside the data, there is another field that is used to identify whether our data has been fully sent. It should be at the very end. When it states equals true, it is finished sending. Okay, so that concludes this lesson. In the next lesson, we will analyze the response data it sent. Thank you, everyone.